Welcome to The Explainer. Today we're doing something really cool. We're going to peel back the layers of reality itself to get at the science that makes everything, and I mean everything, possible. We're talking about chemistry.
Have you ever just stopped and really thought about it? That question, what is all this stuff really made of? It's a huge one. But you know what? It's the exact question that chemistry is here to answer. So let's do it. We're going to start with the world we see and zoom all the way down to the atoms within.
So, to tackle a question that big, we've got to start at square one. We need to get a handle on the field of science that's dedicated to it. So, what even is chemistry?
Okay, so here's the textbook definition. But let's break that down. At its heart, chemistry is just the science of stuff. Simple as that. Think about an iron nail. Chemistry asks, what's it made of? That's iron atoms. What are its properties? Well, it's hard, it's magnetic. And what changes can happen to it? Well, you leave it out in the rain, and it combines with oxygen and water to become rust. That whole story. That's chemistry. And this shows you that chemistry isn't just something that happens in a lab with a bunch of bubbling beakers. No way. It's happening literally everywhere all the time. It's in the air you're breathing right now, it's in the food that fuels your body, and yep, it's happening inside the very device you're watching this on. It's everywhere.
All right, so if you're a chemist and you're faced with this just endless variety of stuff in the universe, where to even begin? Well, your first job is to bring some order to all that chaos, and that starts with sorting. The official sciencey term for all this stuff is matter, and the definition is actually super simple but really powerful. If it has mass and it takes up space, it's matter. Think about that. That means you, me, the air in this room, and even the most distant stars were all fundamentally made of the same thing. So how do chemists start organizing it all?
Well, the first big split comes down to this. Is it a pure substance or is it a mixture? A pure substance, like a chunk of pure gold, always has the same chemical recipe, the same DNA, if you will. Its properties never, ever change. A mixture, on the other hand, like the air we breathe, is more of a grab bag. It's a blend of different things, and its composition can change depending on where you are.
Okay, let's stick with that pure substances column and zoom in. Let's put it under the microscope. What are they made of? This is where we get down to the really fundamental stuff, the building blocks of our entire universe.
I love this analogy. Think of elements as the universe's private stash of Lego bricks. You can't break an element like gold or oxygen down into anything simpler, at least not with chemistry. It is the simplest it gets. It's a fundamental brick, and everything you can see and touch is built from these basic bricks.
And just like with Legos, these elemental bricks come in a few different flavors. You've got your shiny, conductive metals, like the copper in our wiring. You've got your non-metals, like the carbon that forms the backbone of life itself. And then you have this weird but cool middle group called metalloids, like silicon, which is literally the heart of all our computer chips.
So, if elements are the individual bricks, what happens when you start clicking them together in a very specific, unchanging way? Well, then you get a compound. Water is the perfect example. It's always two hydrogen bricks snapped onto one oxygen brick. Always. It's like a pre-built Lego model that has its own totally new properties. But wait, how do these elements know how to combine? It's not just a random free-for-all. There has to be a system, right? You bet there is. There's a rule book, a set of fundamental laws that dictate exactly how these combinations happen.
You know, right around the turn of the 19th century, there was this incredible explosion of discovery that laid the groundwork for all of modern chemistry. It was like one domino falling after another. It started with Lavoisier, who proved matter doesn't just vanish. Then Proust showed that compounds have fixed recipes. And these ideas all led to even more breakthroughs, creating a complete rulebook for how atoms play together.
So rule number one is probably the most famous one. All it says is that in any chemical reaction, you end up with the same amount of stuff you started with. It might look different, but nothing just disappears into thin air. The atoms just get rearranged.
And this one? This rule is the science behind our Lego model analogy. Water is always H2O. It doesn't matter if you get it from an ancient glacier or from your kitchen sink. The recipe, that exact proportion of hydrogen to oxygen, is always the same.
Then, in 1808, John Dalton came along with this absolutely brilliant idea that tied everything together.
He proposed that all matter was made of these tiny little particles he called atoms. And this one single powerful theory, it perfectly explained all of those laws people had been discovering. It was a total game changer.
Okay, so we've got it. Matter is made of atoms, but atoms are impossibly ridiculously small. So that raises a huge new problem, right? How in the world can you actually work with them? How do you count or weigh something you can't even see?
You do it with this. Just take a second to look at that number. It's kind of absurd, isn't it? This ridiculously huge number is the secret key. It's the cheat code that unlocks atomic-level chemistry for us regular-sized humans. So what on earth does it represent?
It represents 1 mole. That's it. And a mole is just a word for a specific quantity. Just like a dozen means 12 or a pair means 2. A mole just means that giant number of things. It's the chemist's version of a dozen, but it's for counting atoms.
And this is why the mole is so unbelievably powerful. It's the magic bridge that connects the invisible world of single atoms to our visible, weighable world in the lab. By using the mole, a chemist can weigh out a substance in grams and know exactly how many atoms they're dealing with. It makes the unseeable totally countable.
This concept is so essential, so absolutely critical, that it earned its own spot in the big leagues. It's one of the 7 base SI units. These are the fundamental measurements upon which all of science is built. Just like we need the meter for length and the second for time, scientists need the mole to measure the actual amount of a substance.
So, from the everyday stuff all around us, down to the rules that atoms live by, and finally, to the clever tools we invented to count them, chemistry gives us the ultimate instruction manual for matter. It gives us the power not just to understand our world, but to create new things within it. So the only question left is, what do we want to build?